Hello GATE aspirants, welcome to part 10 of GATE Nuclear and Particle Physics series. Question number 2. Consider baryon number and lepton number conservation laws. Which of the following processes is or are allowed? So consider first, here we have first reaction. Let us check baryon number conservation. So for proton it is 1, then 0, 0, 0. So baryon number is not conserved. So this first reaction is not allowed. For the second reaction, we will consider lepton numbers. So lepton number, so this will be 0, 0, this will be minus 1, plus 1. And this is plus 1, 0. Now this will be positron. No? So this will be minus 1, then 1, then 0, 0. So these two laws are conserved. Also there is no baryon in the equation. So that means this second reaction is allowed. So only second reaction, option C is correct here. Next question. A massive particle X in free space decays spontaneously into 2 photons. Which of the following statements is true for X? So let us consider charge. So photons have 0 charge. That means this particle X also should have 0 charge. So X is charged, that is not correct. Then spin for photons is 1, 1. So X can have spin from 1 minus 1 to 1 plus 1. So that means 0, 1, 2. These are the possible cases. So spin of X must be greater than or equal to 2. That is also not possible. And these are integral spins. That means X is a boson. And it can't be a baryon because then baryon number will not be conserved. So option C is correct here. Next. Nuclear spin and parity of 40 calcium 20 in its ground state is. So here Z number is 20 and N number is 20. So it is an even nuclei. And for even nuclei, J pi is equal to 0 and parity is positive. So option A is correct. Next question. Low energy collision S-wave scattering of pion with deuteron results in the production of 2 protons. So pi plus deuteron gives proton plus proton. The relative orbital angular momentum of the resulting 2 proton system for this reaction is. Now for this case, parity, it is considered parity. What is happening to parity? So this have parity minus 1. This is plus 1 and proton has 1 parity. And we have to consider here minus 1 raised to L. So this is minus 1 is equal to minus 1 raised to L. That means L is equal to 1. So the orbital angular momentum is 1. Next, a radioactive element X has half-life of 30 hours. It decays via alpha, beta and gamma emissions with the branching ratio for beta decay being 0.75. The partial half-life of beta decay in the units of hours is. Now here T half is given. So that is equal to 30 hours. This is given to us. And branching ratio is given. Branching ratio is 0.75, which is 3 by 4. And that is equal to lambda beta upon lambda. So now let us substitute values of lambda here. So this will be 3 by 4. Lambda beta is 0.693 upon T half of beta. So T half of beta reaction upon 0.693 upon T half. So this is T half upon T half for beta reaction. So this will be 3 by 4. T half for this entire reaction is 30 upon we have this T half beta. So T half beta is equal to 30 into 4 upon 3. So that is 40 hours. So answer here is 40 hours. So these were all the questions from GATE 2019 paper. If you like this video, please give it a thumbs up and subscribe to my channel for more videos. Keep learning.